Hello and welcome to another ARM software developer breakdown. My name is Robert Wolf, and here we are again with Paul Howard, Principal System Solution Architect from ARM, plugging away at this very interesting PARSEC Demo series. If you missed any of the previous parts to this series, please cruise on down to the description and find the part that you're on. So in the last video, we got to follow along while Paul built out the PARSEC command line tool. What do you have in store for us this time?
Thanks, Robert. So now we have PARSEC up and running on our Raspberry Pi, and we also have the PARSEC command line tool, the PARSEC tool, which gives us a nice handy way to do stuff with PARSEC. So we're going to look at a real use case now. Let's see how we can actually use PARSEC to do some simple key management and some asymmetric encryption using a key pair. I'm going to show you how this works just with some diagrams real quick, and then we'll head over onto the Pi screen and we'll do this for real. So we have PARSEC running on our Raspberry Pi. Now I'm going to use it to provision an RSA key pair with the private key stored securely inside PARSEC and the public key made available to third parties. Now this is a common scenario where the public keys are exported for use by an external system such as a cloud service, where they do things like encryption or digital signature verification, and while the private key is kept secret for operations like decrypting or for signing. So we're going to export that public part of the key, and in this demo we're going to export it to a simple online RSA encryption engine. I'm using this website, hgwifi.org, really just to represent any kind of third-party cloud service that might be using the public portion of my key pair to do the non-secret operations. Now in this case, I'm going to use the website just to encrypt a plain text message. So we'll do an RSA encryption using that public key. We'll get the ciphertext from that. We'll bring that ciphertext back over to PARSEC, and we'll use PARSEC to access the secret private key, which can decrypt that piece of ciphertext for us and give us back the original message. Now the PARSEC operations in this demo are going to be performed using that command line PARSEC tool. Okay, so let's see this. PARSEC is running on the Pi. We have our PARSEC tool built, ready to go. Let's head back over to our Pi screen now, and we'll see that in action. Now we're going to start by provisioning our key pair. And for this, we're going to use the PARSEC tool command line create RSA key. Now we don't have to do very much typing here. We just have to specify the name of the key. This is one of the really cool things about PARSEC, is it tries to make a lot of sensible decisions on our behalf. So it's going to choose the best available key strength for us by default. It will create an encryption key rather than a signing key. We can override these defaults if we want to, but it gives us a minimal typing experience for most common use cases. So that's the key created, and we can do that list keys command just to see it. Let's get the public key out now. So for this, we're going to use our second command. It's called export public key. And you'll notice, again, by default, we get the most convenient behavior. Our key has been output there in a PEM format, nice and easy to go and pick that out, copy it to our clipboard, which I'm going to do now. There we go. All right. So let's head over to this hgwifi.org website. So this is outside of PARSEC now. PARSEC is keeping that private key nice and safe for us, but I'm going to take the non-secret public key here and paste it there. Let's type ourselves a little plain text message in there, and it's going to keep encrypting as I go. But once I finish the whole message there, okay, I can just go and scrape this ciphertext now and pop that onto my clipboard. And then it's back to PARSEC for the final step. So we're going to use the PARSEC tool one last time. The tool gives us a nice decrypt command. Again, various ways we can use this command, but by default, if we just specify that key name and then grab our ciphertext from the clipboard and literally just paste it right in here on the command line, PARSEC will treat it as base 64 and decode it before finally accessing that secret private key for us, decrypting the message and giving it back. Okay, there we go. Now, it feels like we're done. We've got PARSEC up and running, we've seen how to use it, and we could stop right there if we wanted to, but we haven't seen the real power of PARSEC yet, and that power comes when we start to think about how well our private key is being protected. And Robert, that's the topic for the next video. So over to you to wrap up this one.
Gosh, Paul, this is really turning out to be quite the demo, and I'm already looking forward to the next part. That being said, why don't you tell us what we're going to be covering in the next one?
Yeah, sure, Robert. So next time we're going to bring in a hardware security module. We're going to add real hardware protection for that private key. And I'm going to be explaining how we can switch the whole of the PARSEC backend over to use a hardware security module instead of the software backend that we've been using so far.
Wow. Awesome. All right. Well, thanks, Paul. I look forward to being there with you on the next one. As a reminder, anyone watching, don't forget to like this video and follow our channel. Stay tuned because the demo will continue.